Okay, I'd like to go through a couple of problems with tangent lines. So we'll do these ones together. Consider the curve y equals 5x cubed minus 3x. I like this bit. It goes to the origin. Find the derivative. Have a go at doing that for yourself now. Find the derivative. Gotta be able to do the simple derivatives. Yep. All right, let's have a look. What do we get as for part A? Sorry. We need dy dx is equal to. Who's going to help me with this one? Right. 15x squared, excellent. Minus 3. 2 marks on a derivative question. Woo! Okay, the curve has a tangent at point P, which is -1, -2. Find the gradient of the tangent at this point. How do we do this? How do we do this? Omar.
We put 1 into the derivative.
We put -1. -1 into the. Okay, have a go at doing this now. Have a go at doing this bit now. Vanya, let's put the phone away.
You just plugged in one and one.
No. Just -1.
I can't see. I can't. I don't have my glasses.
No, Alvin.
Yeah.
He's sitting in the seat. That's where it's going. C minus would be the effect of that seat. Maybe the duty. All right. So B. What do we do here? So we want we want the gradient is going to equal 15, and then we put -1 in here. What do we get as our answer? 12. 12. Let's see how to do it on the calculator. So we could do this on the calculator. I'll show you a slightly different technique. Okay, so calculator, menu, calculus, derivative at a point. Our point is -1. And then here, I'm just going to type in the original function. And just type the original function in if I want. 5x to the power of 3 minus 3x. We get 12. So if you did this method and then you just quickly double check that, if you don't get 12, either you've made a mistake there or you've made a mistake there, and you can help catch your errors a little bit.
How do you know that you're in?
So if you get a 12 here, and you've got a 12 here by doing it by hand, you're good. If you don't get a 12 here, check, oh, what have I done there that's gone stupid? What have I done on the calculator that's gone wrong? What have I done here that's gone wrong? Because one of the three is, if it doesn't verify, it can help you. Find the equation of the tangent and give your answer in the forms y equals mx plus c. Oh.
So you play, well, I'm using y equals mx plus c, is that fine?
Yeah, it's the same.
You said we could use the other one, but I'm comfortable with this one, so.
No, this because you're aiming for that form, then maybe you'll go with that form.
Oh, I see.
Yeah, that's your goal anyway.
So, I included -2 into the
So,
y.
let me give people a chance to do it themselves. If you've already done it, great. Let me give everybody else a chance to have a go, and then I'll take it. I think I will go straight to the MS plus C form for this question. The way it's structured, what information we've got so far, it's pretty quickly into the C. And then okay, one more minute.
MX is 2, right?
And X is X. You lose points in that. So sometimes the question will give you it and say, what is the gradient? And if you give minus 3x, you'll get the points. If you give minus 3, you'll get the points. Are we done?
So I put,
Sorry, give us O more. Go on, I want to give it to me then.
I couldn't solve all the way because I forgot my calculator at night, but I know how to solve it.
Leal, ask next. Go, Leal.
I did y equals 12x plus c.
Y equals 12x plus c.
And then I put in x and y from the point P, so there's -2 equals 12, and then find -1 plus c. And then I did and solve and got c equals 10.
What's your final answer?
Y equals 12x plus 10.
Don't forget to answer the question. Don't forget to answer the question. 12x plus 10. Excellent. Excellent. Let's hope you have peace.
So wait, I have a question. So we put this in and solve, and then we get c.
You can put it in end solve. You can. This is minus 12. We have 12 to both sides. Minus 2 plus 10. I mean, plus 12 is 10. But end solve will do. All right. Have a go at this one. This is a bit harder, this one. It's a little bit harder. Look at the function. You can't differentiate this function yet. What do you have to do before we differentiate? Expand. You have to expand the bracket first, then find the derivative.
Do we move x from the denominator first and up?
No, you got to expand it. This is typically the sort of difficulty you get in one of the last questions on the papers. There was a paper 2, question 5 on paper 2 had a derivative like this. Did you expand?
I don't know how to expand it. I know how to uncheck you, but I don't know how to expand.
So what it's gonna be is you're gonna get 2 over x times x cubed minus 2 over x times x plus 1. Sorry, 2 over x times 1. So then you gotta simplify this. 2x squared minus 2 plus 1 over
it's done.
Distributed property, it's gonna look like that.
Zero to be before X.
So for this one, because we have the rational function, you've got to rewrite it in exponent form.
Come on,
For the second term in the first part of this, when we're solving it, do we also write it as 2x over x, or is that wrong? Like,
yeah, you can't differentiate that without simplifying it first.
so we need to move the x out of the.
Yeah, you've got to simplify it. You could differentiate it like that, in that form, you need to use the quotient rule. The rule cancels, it's a little waste of time. And you guys haven't done the quotient rule.
Yeah.
So would it be 4x minus 4x squared?
It will be 4x minus 2 over x squared. All right, have a go at B.
What happened to just right?
Yeah, because it's a constant, so constant terms disappear, even if they're in the middle.
And why is it a negative?
The negative was given at this point.
Oh, so there's also plus there.
Sorry? Instead of 2 over x squared, can you also say negative 2 over negative, wait a minute. Negative 2x to the power of negative 2.
Negative 2x squared. Or negative 2x to the negative 2.
Yeah, to the negative. Okay.
You would normally get the point for that.
Okay.
This is correct.
No. You're putting minus 8 in. But we want, it says the gradient of the tangent is equal to minus 8, which means the derivative is equal to minus 8. We're not finding the gradient at minus 8. Should be more than one as I don't know. It should be more than one. It says point or point, and it's 4 bars, so you just and solve and get one answer.
Plugging it in my calculator, do I plug in the derivative equals -8 or?
Are you in solving?
Yeah.
Yeah. Don't forget to multiply this. Look at the number of points the question has. And it does say point or points, and then there's 4 marks, so it can't possibly be simply saying equals minus and getting one answer. There's got to be more than one. I don't know if there is, but looking at the points, I'm like, there's got to be more than one. Okay, one more minute.
We just graph this this derivative at a time and then locate the point p and the graph.
That's one technique. There's 3 good techniques here. So you graph the derivative, draw the line y equals -8, and find the intersections.
Yes, I got 2 numbers.
So can we do it?
Yep, ready? All right.
So basically,
Let me go through this question. There is
it's
3 or 4 good ways to solve the question. I am. Let me just double check. I can share it. Yes. There are 3 or 4 good ways to solve the question. Your first point, which I heard most of you getting, is we want this. We want the derivative to equal -8. Now, take care with a question like this. If you just end solve that and get one answer, question yourself. There's 4 points. You can't possibly have got them all. You haven't done enough. So look at the mark scheme. When there's 4 points, that guides you. Think, wait a minute, I'm doing something wrong here. I can't get 4 or 7 points in 2 lines. We catch mistakes that way. What we typically would like you to do is to rearrange this into a and to sort of solve it. So we can rearrange this by moving the 8 across like this. What you should then do is sort of multiply through by x squared, and we're going to get 4x cubed plus 8x squared minus 2. So I've just multiplied through, and we see there it's a polynomial at that point, and we can solve the polynomial. So I'm going to solve the equation in all of the different steps in different ways and show how you get to your answers. So your final point is so you might get a method point for sort of attempting to rearrange and solve. Typically you're going to get 3 answers because it's a cubic. So one way to get the answers is here at this point, the final point. We can press menu, algebra, polynomial tools, and find the roots of a polynomial. This is a 3rd degree polynomial now. Our coefficients are 4, 8, 0, and -2. And then this gives us our 3 answers. Let me just 3 significant figures there. Those are our 3 solutions. So x equals minus 1.85 minus 0.597, 0.452. Okay, these are our 3 solutions. Let me do it another way. So here at this point, when I've rearranged it, I'm going to do it here at this point because I haven't done much algebra to get to here. I've just moved the 8 across. I haven't had to do that times 3 by the x squared, which is a bit more challenging. And that's a good point to graph it at. You can graph it at the original point, but let me just go here, delete that. So here at this point, I've got 4x minus 2 over x squared plus 8. And I get a curve that looks like this. I want to find the roots of this function because I've rearranged it to set it equal to 0. I'm looking for where the function is equal to 0. And this is one of the quickest graphical methods. Let me show you some real tricks I have hidden from you from before. But if we go to analyze graph and find a 0, we move this across. And I'm going to click over here. And then I'm going to move this across. Look, there's my first solution, minus 1.85. But I'm not going to click. I'm just going to keep dragging across. Go a little bit further over here. Look, there's my second solution, minus 5.97. And then I'm going to keep dragging across. Should that pop up the final solution. So it's given me all 3 solutions there. That's a little bit quicker sometimes.
Should we check your step before you remove the digital?
So here, as soon as I got one side equal to 0.
As long as it's 0.
Yeah, and I can do that technique. Okay, let me do another graphical technique. So here at this point at the beginning, I don't want to do any rearranging. You can always solve an equation when you've got 2 sides to the equation by finding the intersection between 2 curves. So graphically, I just enter the function. This is the derivative now. And what I want to do for this technique is I add in a second function and say this is going to be at minus 8. So let me just adjust this. So now I have to find the 3 points of intersection. So menu, analyze graph, intersection. And I want this one. I don't think I can drag across for this. Let me try it.
No, you can't.
Yeah. Look. Dragging across and I find all 3 that way as well. Just note them down. So let's go to our favorite technique, end solve. Let's go to end solve. You guys like to start off here right at the beginning and just end solve the whatever out of that. So algebra, end solve, our trusted friend, minus 8 is equal to 4x minus Ooh. Delete 4x minus 2 over x squared, comma x. One of the problems with AISL is we get one answer. We get one answer. We've got to find more answers. So you have to put in some bounds. At this point, you would have no idea where the next solution is, so we might have to go to 0.5, comma 100, like this, and we put in an interval. There's nothing up there. So you're like, ooh, there must be something smaller. So we will go to minus 100 up to 0. Oh, we found another solution. There could be more. Let's go smaller still. So you've got to keep playing with this. We've got to change the upper bound to minus 0.6. There's our third solution. So we've got all three solutions now, but with AISL, you wouldn't know if there's not more. So we're going to have to go to minus 1.9, and then no solution found. With AISL, you will get your solutions if you keep going and going until you get no solution in each direction, and that will get you there. But I think the graphical methods were the best for this type of question. Very visual. You very quickly see, all right, you see the solutions, so you don't miss them visually. There's no chance once you look at this graph that you're only going to get back the solution. There's less sort of guessing in the air, so to speak. All right. So those are our three solutions. You should see that in the question when there's 4 marks that you've got to do something like that to get there. All right, have a go at this one, a little bit more challenging problem solving.
And this situation is X and A the same.
No.
I'm struggling with this part, but I have a question
Yeah, that was the last method. The last graph, the second graphical method. Sure.
Thank you.
Oh, I get it.
Make sure you write down just the x values. Quickly, I don't know about that. I haven't seen that before. Just ignore the A, imagine it as a number. Just ignore the A. Just leave it in its position and just look at the rest of it. But pretend it's not there, always write it down, you know what I mean? Don't think about it, just leave it.
Is this correct?
This is not correct.
It's gonna be-
It's gonna be like that, but then it's gonna be like this. So two in the denominator. Oh, wait. Like this. And then it's gonna simplify to this. So this one. Okay, we can pause there for a minute so we can do the first two parts together. In case you didn't manage to do the last part, let's make sure we get the first two parts correct. Alright, so question A. Question A is super easy. Super easy. It tells you the answer in so many different ways. So question A, K is equal to what? 0. How does it tell us? We see it here in the graph. We can see the asymptote there at x equals 0. We can see it here in the definition of the function. X is not equal to 0. And we can see here that dividing by 0 is what's going to cause the vertical asymptote. So we can see it in 3 different places. Therefore, k is equal to 0. Find the derivative. So we have y is equal to x squared over 2 plus 2ax to the minus 1. The derivative of this is going to give us 2x over 2. Just ignore the denominators. This one is going to give us minus 2ax to the minus 2. Just ignore the letter a. Now simplify, that's going to be x minus 2a over x squared.
Or if you kept it like that, it would be wrong. Without simplifying.
Usually it's correct. For this type of question, usually it's correct. It is 3 marks, so it might not be. It might only give you 2. I forgot part C.
I can see.
Sorry?
C.
Oh, wait. Let me give you a chance. I'll check it.
I think I got it.
Tell me what it is.
I put an answer.
What did you put?
0.5 equals to 2 minus 2a over 2 by 2.
Okay, how many answers did you get?
This one.
How many did you look for?
One. But to be fair, it's only 2 marks.
Double check. It does sound right that it's only 2 marks, it's going to be 1, because you'll get 1 for setting up your equation, 1 for getting it. But I would double check always. Okay, let's have a look at our answer. C. Yes, you wanted to do this.
Oh, yeah.
we do 0.5 equals x minus 2x over x squared.
X minus 2a over x squared.
And then you plug in x, which is 2.
So 0.5 equals, go on.
2 minus 2a over 2 squared. And then,
Three.
yeah, then you solve.
There's only going to be one answer here on this one. I can see this now. X equals 3. I can see this because the variable is a, and obviously that's just a linear equation. Yeah. All right, that's it for our intro. Take everything off your desk. You're going to